Okay, welcome to part two. I was running out of time at the end of part one and I had to whip through it quickly. So let me just summarize what happened. We just were asked to find the derivative of the following function. And we knew right down here, look at it, right here. This is our formula for finding the derivative. It is just basically the slope formula from algebra 1, change in y over the change in x, but with a limit thrown in. And we did quite a lot of computation, and we used some of our limit tricks of factoring, and we were able to find what this whole limit was. And what was that to us? It gave us a slope generator. If back when I taught logarithms, the big idea was I want you to think logarithms are exponents. Well, for this unit, I want you to think that derivatives are slope generators. That's our big idea. And so I added on to the problem and I said, look, we know this graph passes through 1, 3, and I just picked a point at random. I picked an x value, plugged it in, found the y value. And I could use this slope generator right here to find the slope of the line right there at that point. And it turns out that by plugging in the x value of 1, that it told me that the slope of a line tangent to this curve at that point 1, 3 was going to be 1. And so I could write the equation of the line. The slope is 1. The point is 1 comma 3. And when I graph that line right there, see that slope? Up 1, right 1, up 1, right 1, up 1, right 1, slope of 1. But elsewhere on that curve, that same exact curve, like at the point 0, 4, right there, it's a totally different slope. And so if I plug 0, 4 into my slope generator, well, actually I plug 0 in, the 4 doesn't really matter. I put a 0 in for x, and it tells me my slope is negative 3. Look at that point right there, 0, 4. Wouldn't the slope of a tangent line have to be negative? And so if the slope is negative 3 and my point was x is 0 and y is 4, I get this equation right here. And look at that. There it is, right there. That's the slope. The slope is down 3 to the right 1, down 3 to the right 1. Derivatives are slope generators. So let's take a look at another problem. Ooh, here's one. Write the equation of a line passing through the point 4, 2 that is tangent to f of x equals the square root of x. Ooh, square roots. All right, so let's go back and let's remember our 3 tricks for limits. One of them was just direct substitution. Then we had factoring, and then there was another one. I can't remember what it is. Anyway, here's f of x. Here's how you find the derivative. And if we want to find the equation of a line passing through this point that is, look at this word right here, tangent, we need the derivative because that derivative is a slope generator. So I have my point, I need the slope. And this is our formula for slope, change in y over change in x. I know what f of x is. What's f of x plus h? Well, you just put x plus h in for x, and there's nothing to clean up. This is it. That was a lot easier than the last problem. So let's plug and chug. So I'm going to put x plus h in here for my first y value, square root of x, and for my second y value. Of course, remember, these x's right here cancel out. We just have h in the bottom. Well, okay, so we've got h in the bottom there, and if I try direct substitution, I get 0 over 0, which you know means that it's indeterminate. So what do? Well, in the last problem, I could factor, but factoring doesn't work here. What is the trick I want with square roots? What is the trick? Conjugates. Remember conjugates? So I'm going to take the limit of this, and what I'm going to do is I'm going to multiply by the conjugate. Remember the conjugate? Same numbers, different sign. So instead of the square root of x plus h minus the square root of x, it's the square root of x plus h plus the square root of x. And when I multiply these conjugates out, remember when you multiply conjugates, you just have to do the first times the last. And so what we end up getting here is the limit of course, when you multiply the square root of x plus h times the square root of x plus h, it's just x plus h. Radical x times radical x is just x. The bottom looks pretty bad, but it'd be cool. In the top, notice what happens to my x's. They disappear. And so we end up getting the limit as h goes to 0 of just h over h times this mess. And look right there. I see a Mr. 1 wearing some h's. And so now we can go ahead and we can take that limit because we don't have that single h making the whole denominator go to 0. So if I allow h to become 0, what do we get? We get 1 over radical x plus radical x, which is just 1 over 2 radical x. This thing right here, this is my slope generator. That was a bad color. This is my slope generator right there. Now, I went ahead and kind of rewrote what the problem was. We want the equation to line tangent to this curve that passes through the point 4, 2. So now that I have my slope generator, my f prime of x, my derivative, that's 1 over 2x. I can evaluate that when x is 4. So when x is 4, this becomes 1 over 2 times the square root of 4, which I think is 1/4. So what's that mean? Well, my slope is 1/4. My x value right here is 4, and my y value there is 2. That's the equation of the line tangent to that curve. And you know what you could do? You could graph this equation, y equals the square root of x. You could graph this line on your graphing calculator, and sure enough, you'll see that this line passes through this point and is tangent to that curve. Let's try one more kind of together just to make sure you have it. Let's find the slope of the line passing through the point 3, 21 that is tangent to that function. So why don't you pause the video and give this a go. Hey, welcome back. Hopefully you paused the video and gave this a try. We have our f of x. Remember, to find the slope, we need to find our f of x plus h. So put in x plus h in there. Hopefully you did that and you got that. We know our f of x. We know our f of x plus h. It is now time for you to find the derivative f prime of x, our slope generator, by plugging and chugging. So again, good time to pause and see if you can find this derivative. Hey, welcome back. I hope you actually did it. Here we go. I'm going to show you all of my work for this. Whoops. There you go. I plugged in my f of x plus h. I plugged in my f of x. I distributed the negative. I happened to go down here and say, oh, look at this, that this 4x squared and this negative 4x squared canceled. This negative 5x and positive 5x canceled. I got all of this. I was able to get down here and those h's canceled. And now I could actually take the limit. I could put a 0 in for h, which zeroes out that whole term. And what that ended up giving me was the derivative. F prime of x is 8x minus 5. And remember, it wanted us to write the equation of this line at the point 321. So now that you have the derivative, you can plug in the x value of 3. And I got the slope is 19. So at this point on that parabola, the slope is, it's a pretty steep slope. And now to write the equation, my final thing, I have the slope of the line. Oh, I guess I didn't have to write the equation, did I? Nope, just find the slope. Well, let's write the equation anyway. We've got the time. So the equation is, I'm going to come over here, y minus 21 equals my slope, which we said was 19, times the quantity. Oh, this is a terrible way to write. Times the quantity x minus, what's the corresponding x? 3. So their little bonus was your equation. Your homework is attached in a PDF. You have some problems where you're just finding the derivatives, and you have other problems where you are writing the equation of a line. Now, I will say this. There are shortcuts to derivatives, and I'll guide you to them next week, but no shortcuts allowed in this week's homework. No shortcuts. Next week, the final shortcut club.